This one has been quite a project. This thing started out as one of these inline needle valves. This particular one is compression on both sides. Another variety that was available at the hardware store was compression to pipe thread. That would also have worked because one of these threaded ends here I cut off and then soldered onto that one of my air horn threaded pieces so I can screw it on to the butane tank. Now in here, in order to seal and also activate the valve, I've done it up basically the same as I've done with my early version of the butane tank adapter, with the stainless steel probe and no O-ring. However, this one here, I've made it a lot narrower. I chucked it in the drill and used a file to reduce the diameter, because this one here was kind of large and it was sort of chewing up that inner seal inside the tank. And so with this one I made it more slender so that it fits better. Inside my stainless steel probe there, I have a little broken off piece of a 1/16 inch drill bit, and the purpose for that is when that probe is forced down inside the valve, there's a plastic piece inside the valve that will actually plug that tube up, and so you won't get any flow coming out. And in this one, that's what I've cut those notches in there for. But those notches combined with the large diameter of that inner probe was chewing up that inner seal inside the tank. And so the only way to avoid that plastic valve piece plugging up the probe is to not allow that little bump in the plastic piece to go up inside the hole. And so I've got a little piece of drill bit, and the reason why I chose a drill bit is I didn't want to completely plug my probe, and so the drill bit flutes allow gas to pass around it. Now on the top here, this piece I'm screwing off now is just that hacked up blowtorch burner tube with a piece soldered on top and a bunch of copper wire jammed in the top. And now here is where one end being a compression fitting is important, because that's how I've designed my new orifices to be. And I'm going to get a wrench. I'm going to loosen this up. I'm going to show you what's in there. Okay, now that that's loose, I'm going to unscrew it. This top piece is the compression cap that threads onto here, except instead of having the standard one with the hole in it, I bought a compression cap. It screws on there just just like the other piece, but it's solid across the top. And onto the top of that I've soldered a very short section of what this used to screw onto, and I've soldered that onto here so I can screw my burner tube onto this piece. And here we will see how I'm doing the orifice in this stove. Here's the compression cap that just came off. And here is my orifice. And don't let the black dot fool you, that was just a mark I put on there to tell me where to make the hole. This is just a very small circle of aluminum soda can. I cut out a little circle, and I'm going to see if I can, maybe if I flip it around, I'm going to see if I can get this up to the light. There you might be able to kind of see a hole in there. The purpose of using the aluminum can circle as my orifice is I can pierce this with a pin, and depending on how far you pierce it, how deep you push the pin in, determines how big your hole is. So if you really don't come out the other side, you end up with a very small hole. And if you screw it up, which it's very easy to do, well, you just throw this away and try again. It's no big deal. I thought about taking my 1/8 NPT plugs, or say like this compression cap, and drilling it almost all the way through until I had a very, very thin layer of material just before the drill bit broke through, and then piercing it with a pin. But that has the problem, if you screw it up, well, now this thing's garbage. You've ruined it. Whereas it's no big deal if you screw this up. And the way that I'm able to use this as an orifice is inside my valve assembly here. I've got a small piece of copper tube pushed down in there. And so when you thread your cap on, you thread that on, and the top of the cap mushes down onto the top of this. It smashes down and seals on it, and seals anything that's in between it. The hole that I've drilled into here isn't too terribly important. It just needs to be big enough so you can see what you're doing, but not too big that you no longer have that shiny area in there to press against and seal against this tiny piece of copper tube. And so what I do to make the orifice, I really ought to get a hole punch. I could probably crank a bunch of these out, but I just cut a very small circle of aluminum can and I set it on there like this. And then I take the compression cap and I screw it down and I snug it down, and that bends that little disc into that little cup shape. But more importantly, now through that hole I take a fine tip Sharpie and I mark on the orifice where the center is. And then I remove the compression cap. Take my newly formed disc with my mark in the center, and then that's when I pierce the hole with the pin. And after I'm done with that, it goes back on, and then when I reinstall the compression cap, I really cinch it down to seal it up. I also use that mark that I made earlier to make sure that the orifice is still centered before the final tightening, before the final snug down. There it is installed, and now I'll screw my burner tube back on there. Looks a little bit crooked.